Alright, so this is like trying to get the regression equation from computer printout, which is like this really old school way of printing it out. I think more modern statistical programs do a little differently, but they're still want you to know how to read these. You read through that World Cup soccer matches, saying there's a negative relationship between the number of fans and the number of total goals. Negative means when one goes up, the other goes down, like a negative slope. They're saying if there's more fans, there are less goals. There's less fans, there are more goals. But you don't really even need to know that. Your job is to write the equation, and it basically comes from here. This is your x value. You know how the equation of a line is y equals mx plus b? Or in our case, we put the hat on it because it means predicted. Well, this is the number next to the x, because it's like, hold on, I covered up the negatives. This is the number that's listed like with the x or next to the x. That's your m, that's your slope. And then this is the constant. Well, what does constant mean? It's just a number just chilling by itself. Like that's what this b is. That's what b is. It's the y-intercept. It's a constant. This number here is your b. That's how the tables will always be set up, and that's always how you read it. X value, slope, y-intercept. Every time. So in this one, it would be y hat equals negative 0.009 times attendance, or times x, plus 3.260. They're saying use the model to predict total goals if there were 90,000 fans. So what do I do with that 90,000? Stick it in for attendance. Or you plug that in and get whatever that is. I don't really want to do it. Let me go to the next one, just show you another. Is that okay if I move on, or questions on that one? You telling me or you telling them? Gotcha, yeah. So down here it says like where. Yeah, like right in front of your face. So, I don't know, let's say it's 2. I don't know, probably wrong, but. Are you serious? That was amazing. That's like the first time I've ever done it. Did you just guess one too? Alright, so same deal. I'm just going to write from over here. What's this? That's your x variable. What's this? That's your m, or your slope. What's this? Y-intercept. So my equation would be y, don't forget the hat, equals negative 5.97. This is painful, I'm sorry. Plus 89.7. And then they're saying the fertility rate is 2. So what do I do with that 2? Stick it in right there for x. Calculate it, see what you get. Is that fair enough? Alright, so let's start working on the sheet I gave you too. I took my table all the way down there, so now I have to sit in this tiny little chair and teach you. Just talk to 3 people. You guys ready back there? You guys ready back there? Yeah. Alright, none of this matters. Cross all that out. So number 1, find that. So this is the LSRL is least squares regression line. Just by the equation. Get that? So what does amount represent? It's x. Coefficient of that x is the slope. It's the number in front of the x. The number in front of the x is always the slope. And then constant right here is your y-intercept. So remember, there are two ways to write this equation. I'll go through both. I can say y hat equals least squares regression line. You can't see that. There's not much of it. You can put it in the front. Is that good though? Okay. So you can say y hat equals 9.5x minus 2.679. But there's no context in that equation. You would then have to include context and say, okay, hey, by the way, y equals height.
Please excuse the interruption for picture retakes. H through K can please go to A105 at this time. H through K. And remember, if you're not purchasing pictures and just need a student ID, please go and have your picture taken.
And x equals, say, amount or detergent or grams or whatever you want. So here I wrote the equation, and then I declared what y and x was. The other way I could do it is to put these variables into the equation. You could say like height hat. Remember, what's the hat mean? Predicted, expected. Equals 9.5 times amount minus 2.679. So one or the other. I don't care which one you do. Both of them tell me the slope, 9.5. Both of them tell me the y-intercept, negative 2.679. Both of them tell me what y is. Both of them tell me what x is. And both of them tell me that it's predicted. Alright, find and interpret the slope. So you notice this, we're just hitting this over and over and over again. So the slope is 9.5. So you can think about that like 9.5 over 1. And that's like your y over your x. So as x, which is amount, goes up by, if I look at my little fraction here, what's x next to it? 1. So as x goes up by 1, remember we expect height to increase or decrease. Increase y. It's positive. By 9.5. Sorry, I gotta zoom out a little. Can you still see it?
Yeah, I already wrote it down.
You're like, I don't
I
care.
was going along.
Really? Okay. Find and interpret the y-intercept. So the y-intercept is negative 2.679, or if you really think about what point that represents, it's 0, comma negative 2.679. That's like your x, comma your y. So we would say if amount were 0. Can you see? You're good? Not used to this. I don't know if you see. It's pretty tall. If amount were 0, we expect height to be negative 2.679. Good on those? Find and interpret R. So I might have crossed off too much here. Sometimes this chart will give you R squared and R squared adjusted. Never use the adjusted. But this basically tells us R squared is 0.969, 96.9%. but I want r in this case. So what do I do with that r squared to get to r? Square root it. It's above x squared, so you're gonna get like second x squared. You see it on the left hand side? I don't know who said how do you do that. So the square root of 0.969 is 0.984, and that's your r. And so if we're interpreting r, I could actually say this is linear because I can see the data, and it is. I don't have to. I do want to say if it's strong, moderate, or weak, so 0.984. That's strong, right? Positive or negative? Positive is going up, and then remember context. So there is a strong positive relationship between amounts and type. We're still good? Final interpret r squared, cross that out. And then number 7 is what I really, so part of that was review, part of it's computer thing. 7 is what I really want to get into a little bit. And B got cut off for some reason. So over here, put B, y-intercepts. And we're going to add a point to this data at 10, comma 5, 10, comma 55. 10, comma 55 would be like over here. Where the dot is. And then I'm asking what happens to a bunch of things. So remember the dots that are like endpoints are really influential and they pull the line toward them pretty strongly. So wouldn't this line kind of be drawn that way a little bit? So if I do that, what's happening to my slope? It's decreasing, right? Remember my elbow is like the y-intercept, so what's happening to my y-intercept? Increasing. And then for r is like how close points are to the line. It's kind of, you can kind of think about it like the average distance from the line. It's not really that, but kind of. No, that's no, I shouldn't say that. I mean, ask it a different way. Does this make the relationship stronger or weaker? Weaker because it's like really far away from the line, right? So is r going to be closer to 0 or further from 0? Closer to 0. So because it's positive, closer to 0 means it's going to get smaller, right? So my slope, my new line would probably look something like this. I don't know if I can pull it that far, but so my slope would decrease. My y-intercept would increase. These two are always opposite. Right? And then r, we said would decrease. And don't worry about r squared. Alright, so remove that point, so it's gone now. I'm not like adding a second point, we're pretending that the first point didn't exist. I'm going to put a point at 5.5, 90. That point is, like way up here. And realize the way I'm asking this question. Tell whether each of the following would increase, decrease, or no major change. So this is not an endpoint. This is not an influential point. So if you remember when we did this on when I showed you the graph on the Google Sheets, the new line would go from here to like here. Like it would barely bump up because this is not an endpoint. Endpoints are the influential ones. So when I say what would happen to the slope, increase, decrease, or no major change, there'd be no major change. And if I ask what's the reason, what would you say? It's not an influential point. It's not like an endpoint. Same thing for y-intercepts. And then R would definitely cross out R squared. R would definitely be a major change. Like that point's really far away from the line, so did we just increase or decrease the strength? Decreased it, so our R would decrease. Questions there? For 11, would it be appropriate to use this model to predict the height for 6 grams of detergent? So this is getting into like interpolating versus extrapolating. 6 is within my data set, so we're totally fine. Like if you said, what height would you predict if there were 6? I would go to 6, look at my graph, and go over to it's like 55 or something. It's only 5. But if I said, could I use this to predict what happens if there's like 20 grams of detergent? Do I have any idea what happens over here? I do not. So you can't just assume this pattern continues. It could be that at this point it just goes flat. At this point it goes way up. At this point it goes down. I have no idea. So you don't want to let's call it extrapolate. Using data you have and just assuming it continues in that pattern, that's not going to be the case. Or not necessarily going to be the case. So would it be appropriate to use it to predict the height for 6? Yes. 6 is within our data set. Would it be appropriate to use this for a height of 15? No. 15 is outside of our data set. So that's called extrapolating. You don't have to really know that word. You just describe it. Alright? Try that next one, 33. So there's the 2 ways you could write the equation. You're not done yet, don't look. I'm not done the rest of it. Okay, bud? You guys remember when I guessed that kind of answer? That's my goal most days. Try to impress people. This is like terrifying, Dave. Is my brain actually shrinking? If I need sugar. Here's your two equations. You write either way. For the expected one, you plug in 100 for blood sugar, and I got 0.432. You guys get the same thing? Then find and interpret the slope. So as this is what, like, when I start thinking through this, it terrifies me. As blood sugar goes up by 1, brain shrinkage goes up. I'm sorry. By 0.161. So I forgot to put we expect, so I'm going to fix it by saying on average at the end. That works too, just a different way to say the same thing. I should have said we expect, but on average works as well. Or we predict. All got the same thing. And I'm never eating sugar again. Questions on 33 there? 34. And we'll probably save the rest after this until Monday. This is where you're looking for the data. They gave you a bunch of extra stuff there, but that's where you're at. This what makes me happy. If I exercise, I'll run faster. Someone have a question on the previous one? Sorry, am I going too fast? You guys good? Oh, did you go to the bathroom? Did you just walk in? Like how long ago? I had no idea. Oh, you left for picture things? I seriously didn't notice that. How'd they go? Did they go okay? So one of those two ways to write the equation. I'm a little worried. How many of you are remembering to put the hat on there? That's cool. Oh yeah, what's cat mean? So if someone says like, I was going to say no cat. It means like for real. Like, shouldn't I assume everything you say is no cat? Yeah, so that just means like don't trust me unless I say no cat. Like, so the second one you should get 66.01, no cat. Find and interpret the y-intercepts. If we exercise 0 seconds, we expect time to be 88.01. So if you don't exercise at all, they predict that you would take 88 seconds to run around the track. Why? Where's that come from? All right, that's all I got for today. slip into use it to like review on Monday, and then on the AP packet. That'll make me laugh, but it won't. Remember test on Friday. So your eyes do for your tests.